From our previous discussions, you've learned the different types of plate boundaries, which are the divergent and convergent boundary. Now, we will be discussing the third type of plate boundary. In grade 8, you were introduced to different types of folds such as normal, reverse, and strike-slip folds. You also learned that folds are fractures in the Earth's crust created by different types of forces acting on the lithosphere. There is one type of plate boundary that resembles the strike-slip fold. Though much larger, transform fold boundary is similar to strike-slip fold in terms of the relative motion of adjacent slabs of rock. To find out more about this kind of plate boundary, this presentation will let you understand the event that could happen out of this boundary. Transform fold boundary. Transform plate boundaries are locations where two plates slide past one another. The fracture zone that forms a transform plate boundary is known as a transform fault. Most transform faults are found in the ocean basin in connect offsets in the mid-ocean ridges. A smaller number connect mid-ocean ridges and subduction zones. Transform fault boundaries are also known as conservative plate boundaries because they involve no addition or loss of lithosphere at the Earth's surface. A transform fault or transform boundary is a fault along a plate boundary where the motion is predominantly horizontal. It ends abruptly where it connects to another plate boundary, either another transform or spreading ridge or a subduction zone. Although most transform faults are located within the ocean basins, there are few that cut through the continental crust. An example of this is the San Andreas Fault. The immediate concerns about transform fault boundaries are earthquake activities triggered by movements along the fault system. Most such faults are found in oceanic crust where they accommodate the lateral offset between segments of divergent boundaries forming a zigzag pattern. A smaller number of such faults are found on land, although these are generally better known as the San Andreas Fault. A transform fault is a special case of a strike-slip fault that also forms a plate boundary. Don't you know that a strike-slip fault is not a transform fault? Transform faults can be distinguished from the typical strike-slip faults because the sense of movement is in the opposite direction, as what you've seen in the illustration. A strike-slip fault is a simple offset. However, a transform fault is formed between two different plates, each moving away from the spreading center of a divergent plate boundary. When you look at the transform fault diagram, imagine the double line as a divergent plate boundary and visualize which way the diverging plates would be moving. A smaller number of transform faults cut continental lithosphere. The most famous example of this is again the San Andreas Fault Zone of western North America. The San Andreas connects a divergent boundary in the Gulf of California with the Cascadia Subduction Zone. Another example of a transform boundary on land is the Alpine Fault of New Zealand. It was stated at the beginning of this module that majority of tectonic activities like earthquakes, mountain formations, and volcanic activities happen along or near plate boundaries. But there are some cases wherein activities take place in the middle of a plate. Let's take the case of the Hawaiian Islands. Here, we can find some of the largest and most active volcanoes of the world. If we're going to look at Hawaii, it is situated right in the middle of Pacific Plate and not along the boundaries. And finally, we're done with our topic, which is the different types of plate boundaries, namely convergent boundary, divergent boundary, and transform fault boundary. Hope you learned from the discussion. Please do not forget to subscribe for more science discussions. Thank you.